This is Monitoring Raspberry Pi with Nagios. Please welcome Scott Lee.
Good morning, everyone. So my presentation today is very much meant to be a light and fun one. And the reason I say that is because I assume there's no enterprise companies doing something like using Raspberry Pis to power their compute infrastructure. But I do think it's a great creative exercise to think about ways you can utilize something like a Raspberry Pi in your environment. Depending on what field you're in, there's probably many possible interesting applications of a device like this. But today's talk will focus on some interesting projects that you can work on your own, especially if you like making things, and how Nagios can kind of augment and enrich those projects through its alerting and monitoring capabilities. Even if you don't enjoy making things, hopefully this will spur some interest. And I also think it's a great way to spend time with, so if you have a son or daughter or even a niece or a nephew, I think it's a great way to spend some time with them and get them interested in technology projects and help spark their creativity. I think building physical things can be really rewarding, so to introduce someone to that is probably a lot of fun. So this is basically a Raspberry Pi 2. It's the latest iteration in the Raspberry Pi family. And it was released earlier this year. And it has a 900 megahertz quad-core ARM Cortex A7 CPU and 1 gigabyte of RAM. You probably can't tell from the size of this image, but the size of the Raspberry Pi from this image, but it's about the size of a credit card. And if you already don't know what a Raspberry Pi is, it's basically a small computer. The first version of this was released in early 2012, and it was developed in the U.K. It's gone through several iterations since then. The Model A, which was the first version, started off with 700 megahertz, a 700 megahertz single-core ARM processor with only 256 megabytes of memory. I guess as technology improves, you get and gets cheaper, you get better iterations of the Pi. So you can probably look forward to more versions of the Pi in the future. And this is kind of like a schematic of the Raspberry Pi. Things that have changed from Pi to Pi are the processor and the memory, of course. But other things that have changed over time include the number of USB slots, the power ratings. And what I mean by that is it used to only support 1.5 volts, but now it supports up to 4 volts. And slight board configuration changes. So they've moved things around on the board for various reasons. Otherwise, there's always been an HDMI port, an audio jack, a USB power slot, and an Ethernet port for network connectivity. And the original intention behind creating the Raspberry Pi was to provide a low-cost computing device that could be deployed as a teaching tool for both adults and children. And fortunately, we have access to much more powerful computers, but unfortunately, that's not the case for other people. Not everyone in the world has access to high-power devices, even in the U.S. So I think this is a great mission. But even though we have access to much better devices, you probably know that the Raspberry Pi has taken off, and the reason is for its extensibility. There's a lot of sensors that you can use to build interesting projects, and so those sensors really enhance the Pi. So to get started, if you want to use the Raspberry Pi, you need an OS, and you load that onto the SD card. And one of the most popular OS distributions is Raspbian. And it's Debian-based, and it contains over 35,000 packages that are built and optimized specifically for performance on the Raspberry Pi. Another popular OS distribution is Snappy Ubuntu Core, which is also a Debian distribution, but it's better suited for the newer versions of the Raspberry Pi for its ARM7 CPUs. And then there's various OS distributions depending on what you want to do. So one that I'll go over later is called Retropie, and so if you want to build a gaming device out of your Raspberry Pi, that's the OS that you would probably go with. And this is the graphical interface to the Raspberry Pi. The neat thing about the Raspberry Pi is that you can access it remotely, so you can SSH in. You'd have to be on the same network because the Raspberry Pi only has a private address in the 192.168.x.x space. But so you can access it remotely from another computer if you're on the same network. You can also access the graphical interface using a package called VNC. So that's very convenient. So you don't have to use an external monitor or a keyboard or something like that. And I would say these three things up here are the selling points of the Raspberry Pi and what make it unique. So it's the cost, the size, and the sensors. So first for the cost. The base Raspberry Pi is always been about $35, but there's also a lot more things you need than just the base Raspberry Pi. At the minimum, you would need the micro SD card to load the OS and a power supply. For the power supply, you can usually use any kind of Android charger, so that's convenient. But other nice-to-haves include a Wi-Fi dongle, so you don't have to use a Ethernet cable. You can just connect wirelessly to the network, and a case just to protect the Pi. And you can actually buy these all in a bundle for about $70, and that includes the Raspberry Pi. Also, like I mentioned before, you need a keyboard and a mouse and a monitor, and as well as any other accessories you might utilize while working with the Pi. But if you use something like VNC or SSH remotely into the Raspberry Pi, you actually don't need these things like the keyboard except for initial setup. And the size, like I mentioned before, it's about the size of a credit card. It's only about 3.3 inches by 2.2 inches, and it's very light. It's only 45 grams. And I think that affords you to do things that you normally couldn't with a regular sized computer, even a laptop or a tablet. So some projects I've heard of include using a Raspberry Pi to kind of monitor your data center temperature. Of course, that might not be the most efficient way to do it, but it's an interesting way to use it because of its size. The extensibility of the Raspberry Pi is the sensors, and that allows you to do a lot more with it than just use it as a teaching tool. And this slide shows the sensors that you can utilize. And probably the most popular one is the camera board module. It's also one of the most expensive for $25. And an interesting thing that I've seen with the camera board module is a night vision version of it. So you could probably come up with some interesting projects with that. Some other interesting sensors that you could utilize are an analog accelerometer for measuring motion and tilt, a force-sensitive resistor for gathering pressure and force data, and a temperature sensor for gathering, of course, temperature data, and a photocell sensor for gathering light data. So on the diagram on the left, you can see the layout of the GPIO pins. So GPIO is just another way to refer to the I/O pins, general purpose input-output. These pins are basically a physical interface from the Raspberry Pi to the outside world. You can basically manipulate them to gather data. So on the diagram on the left, you see that there are 17 GPIO pins in yellow, and there are 5 ground pins in black, and then 4 power pins in orange and red. On the right, you can see what that actually looks like on the physical Raspberry Pi board. You can damage the board if you don't utilize these pins correctly, so you want to be careful. You might have to pull out your old high school physics textbook and recall how things like currents work. But if you do want to work with the pins directly, another accessory that you would get are male to female pins. And if you're not that comfortable, you can get a breakout board, which makes it a little bit easier to work with these pins. And some projects even require soldering, so you want to make sure that you know all the requirements ahead of time. So this is just another layout. It's basically the previous image flipped horizontally. So there are kind of 2 naming schemes to work with these pins. The first one is the board option. Basically, on the diagram on the right, as well as the diagram on the left, you'll see the pins, and the topmost left one is pin number 1, and the topmost right one is pin number 2. If you go down to the next row, the one on the left is 3, the one on the right is 4, and so on as you go down the rows. So the board option naming scheme is just that. You refer to the pins by the numbers. There's also a naming scheme called BCM, and you can see labels on either side of the diagram on the right, and so that's how you would refer to the pins. That actually changes by Raspberry Pi board versions. So if you're using multiple version types of Raspberry Pis, you want to be a little bit careful with that. Or if you're moving a project from an older Raspberry Pi version to a newer one, that's something you'd want to be careful of. And another thing you can see that's changed from the previous diagram is there's much more pins on this one. The previous one had 26 pins, and you can see that's for older versions. On newer versions, you'll find 40 pins, allowing you to utilize more sensors. So how would you utilize this? One of the most popular languages that you can work on the Raspberry Pi is Python. And Raspberry Pi has this built-in library called GPIO. So you would just import that library, rpi.gpio. And then, like what I talked about before with the set mode, here I'm using the Broadcom channel number option, so BCM. You would set that kind of naming scheme. And basically, there's the hello world of Raspberry Pi, which is where you basically connect an external RGB, like red, green, blue LED, and you can have that pin light up. And so we call that the hello world of the Raspberry Pi. And so here, I've set pin 18 as the output pin, and that's where you would connect the LED. And then on the final line, the output, I would set it to high, so that would drive the pin to produce 3.3 volts of current, and then that would make the pin light up. And so there's much more to it than this, actually, but this kind of gives you an idea of how that works programmatically. Once you have all that set up, you'd want to have Nagios Setup. What I like to do is just set up an external EC2 instance and have Nagios run on that, and just run something like NRPE on the actual Raspberry Pi. But like I said before, if you do something like that, you want to be careful because you can only access the Raspberry Pi through its private address space. So you'd want to set up port forwarding on your router, or use a service like Weaved, which kind of sets all that up for you. And then, of course, you can set up the Nagios software directly on the Raspberry Pi, which it can handle, but you might want to use a lighter version called Nagios Pi, which is built specifically for Raspberry Pis. It's built using PHP. I don't know that it's still being worked on and being developed anymore, but it gets the job done. And once you have either one of those options set up, you can set up custom checks with Python, Ruby, or Bash, and using those, you can collect sensor data from the actual sensors. So I'm going to give you some concrete ideas of how you can utilize the Pi. As I mentioned, the camera sensor is probably one of the most popular sensors. So for instance, one thing you could do is set it up as a home monitor. So if you don't want to go to the door to see who's there, you can just have this camera running and see who's at the door for you. And if you have a pet, you can use it as a pet monitor. So if you're out of the house, you can see like what your pet's up to. Actually, this is probably best utilized with the motion sensor. So if you sense movement in your front porch or something like that, you can have it take a picture through the camera module and then have that alert Nagios, which can then send you a text message or an email alert with like a video or quick snapshot. Also, if you don't want to purchase expensive accessories, the motion sensor by itself is pretty low cost. So if you want to use it as a low-tech detection system, if there's someone going into a room of your house and you want to know about it, you can have the motion sensor kick off and then alert Nagios and then have that send you a notification. And then there's also something called GE link bulbs. So these light bulbs are connected to the internet. And you can set that up in conjunction with the motion sensor. So instead of coming home and fumbling through in the dark to try to turn on the lights, you can have it sense motion and then automatically turn on the lights for you. So those are some creative ways you could utilize these sensors. And this is a sound sensor, and I actually find it pretty interesting how much noise pollution we endure day to day. We kind of get used to it and we adapt, but we don't realize the potential damage it can do to our ears. So an interesting project is you could gather how much noise pollution there is and kind of graph that and create reports of that and kind of see which parts of your day are the noisiest and what kind of potential damage it's doing to your ears. So this is a temperature sensor. This one actually has a humidity sensor built in, I believe. So the obvious project here is a mini weather station. But I thought another interesting project would be to use this water sensor on the right. And if you're doing something like growing plants or growing indoor plants, you can take more of a quantitative approach to that project. You can gather data on how consistently you're giving certain amounts of water, or how the temperature and humidity fluctuations in your house or outside are affecting the plants. So it's more of a metrics-driven approach to a project like growing plants or some other project. Earlier, I talked about Retropie. So you can turn your Raspberry Pi into a gaming system. The OS you would use is Retropie, and the only accessory that you would need is a USB controller. So it's pretty cool. You can actually get some ROMs online and play old gaming systems like Nintendo or Super Nintendo, which is a lot cheaper than buying like an Xbox or a PlayStation. But yeah, these are some of the projects you can work on, and as you can see, there's many, many different sensors. I've only talked about a handful of them, and you can combine them in multiple ways. So the next thing that I want to talk about is the Internet of Things. If you don't know what this is, it's the idea of everyday objects being embedded with software and sensors, and most importantly, network connectivity. So what this allows you to do is control objects remotely, like through your mobile phone, but it also allows these objects to communicate amongst each other and share data. And to give you a concrete idea of what that might look like, something that's not too far off is self-driving cars. If those self-driving cars can communicate with each other and send each other data, you can get an idea of how much traffic there is on the road, how fast other cars are traveling, and I think this improves the experience as well as it provides some safety aspects. Some IoT devices that you can buy currently are the Nest thermostat. So Nest has built a smart thermostat, so kind of like with the light bulb example I was giving, it can adjust to your temperature preferences. So as you move from room to room, if you like it a little bit colder, it can automatically adjust the temperature for you without you having to go to the console and adjust it manually. Also, if you leave the house, it can be smart enough to automatically lower the temperature, so you're saving energy costs. And then let's say the weather changes dramatically and you want the house to be warm when you get there, you can remotely adjust the temperature from your phone. Some other IoT devices include like Google Glass or Apple Watch. And sometimes it takes a while to see the utility of these things. I would consider like an Apple Watch a luxury item, but there are developers who are producing interesting things, and I think there will be much more interesting things with these types of objects down in the future. And then, I think there'll be a lot of value add over time, even though you might not see it now. And one interesting thing that I haven't actually played around with myself, but that I thought was really cool was the Intel Edison. So as you can see from the picture, it's about the size of an SD card. On its longest end, it's no more than 35 millimeters. So this chip here includes a 500 megahertz CPU, 1 gigabyte of memory, a built-in Wi-Fi, and Bluetooth. And it's about $75. So you might be thinking to yourself, why would I pay more money for something that's not as powerful as a Raspberry Pi? While the Raspberry Pi was originally built to be a teaching tool, its use as like a tool to build projects and all of these things, it's actually kind of an accident. So the Intel Edison was actually built specifically for IoT devices. So when you're using an IoT device, the power consumption is very important. You don't want powerful CPU draining all the power, so how you utilize that power is very important. So you don't always necessarily need a very powerful CPU. So an example of this that I saw was someone had built a bicycle helmet with an Intel Edison embedded within it. So I thought it was really interesting to take something that hasn't changed in a long time and make it smart. So as you know, bicycle riders are prone to accidents. So what this helmet would do is if you have some kind of accident and there's some sort of impact on the helmet, it could automatically alert someone for you. So if you're incapacitated or it's a pretty serious accident, it can alert someone automatically. Or you could just like press a button and have it alert someone for you. And I can definitely see this carry over to other fields like construction. So if you're on a construction site and you have some sort of accident, the hard hat could automatically sense some kind of accident and alert the site leader. So I think there's a lot of interesting applications with this here, especially due to its even smaller size. And I definitely see other types of chips coming out that make it even easier and to create projects and create even more creative projects. And I think monitoring is more important than ever with these sorts of smaller chips. It's hard to physically examine these devices and see what's going on because they're so small. And if you have a tool like Nagios, you get a better idea of what's going on, like why something's not working, what exactly isn't working, and if it's possible to be fixed. Sometimes with these devices that come out, sometimes it's easier just to buy a new one if something happens to them. Like if my iPhone screen cracks, sometimes it's too cost prohibitive to repair it. I might as well just get a new iPhone. I think it's important that you are aware of what's going on, and a tool like Nagios helps you to understand that. And I really think the Raspberry Pi has fueled a movement for building hardware. I remember when I was younger, people would build their own desktop computers, and I thought it was really cool. But a lot of that went away. You really don't see people building their own laptops. But I think the Raspberry Pi has really fueled people to start building things, and you see a lot of great Kickstarter projects, people producing items that you normally wouldn't see. And of course, advancements in technology like microchips have allowed you to work with the Raspberry Pi and things like the Intel Edison. And things like 3D printing allow you to more easily create things. And I think it's great that the software allows you to create things, but creating things through hardware, I think, kind of moves like a different part of your brain. So if you're interested in building things, definitely I encourage you to keep doing so, and I'm interested to see like what other things people will produce in the future. And that's basically it. And if anyone has any questions, I'd be happy to answer them.
Thank you. I was looking at possible options for monitoring relay switches.
Okay.
I think this would be a good facility to do that.
I believe you can monitor relay switches directly with Nagios, can't you?
I don't know. It's a
Okay.
question.
But yeah, I guess like if you just want to start a project with a Raspberry Pi board, or even a smaller chip, I think it's definitely worth your time.
I actually got a comment, not a question, but we actually deployed Raspberry Pis about 2 years ago and are monitoring with Nagios for bandwidth monitoring and network monitoring. We didn't have Cisco Prime or anything at that time, so buying a fleet of Raspberry Pis. We're a college campus, so I just deployed these wirelessly and wired all over campus through all the dorms to capture the end user experience. And we do iPerf checks back to the data center and to Amazon Cloud. And it gives us really good data points for a super cheap network monitoring. Like we could see the user experience on every dorm, every campus, and it all reports back, and it's been brilliant and really cheap and easy to do.
Thank you. Yeah, there's definitely a lot of like silly projects you can do with this. Like, so I work for Amazon, and there's actually a space called the Loft where developers can come and get help. And just to show like what you can do with a Raspberry Pi, someone built a kegerator monitor. So there's a keg in there with beer, and you can kind of monitor how much of it is being consumed. So it's pretty silly. It's not anything really beneficial, but it's an interesting way to utilize something like that. But of course, there's much more beneficial projects like the ones that you just mentioned.
Any other questions?
So with the Raspberry Pi, are you just limited by, I guess my question is, how many sensors can you have per Raspberry Pi? I mean, is it just depending on how big the board is, or what goes into that? I mean, how many sensors have you seen can be used on a single Raspberry Pi module?
Yeah, I think it would just be limited by the number of I/O pins that you have. I've not seen anything really crazy where they're hooking up like, 40 sensors or something. But yeah, I guess it's depending on the project, you could utilize that. And I'm not sure, but I think you can probably extend that somehow, like using another breadboard or something like that. Yeah.
Anybody else? It's hard to see back there.
One of my coworkers a few years back hacked computer case fans to make airflow detectors. Now, I'm interested in doing this with one Raspberry Pi, one vent and two big cracks. Now they're pretty far away from each other. So get the proper sensors, what's the limit on distance for the cabling? Or would this be possible?
So the wires come in various sizes depending on what you want to do. So you can just search for the appropriate length wire, and then I'm not sure about this either, but I'm sure if the available wire lengths aren't like what you're looking for, I'm sure there's some way to, I'm sure someone's come up a way to extend them somehow.
Anybody else? All right, ladies and gentlemen, how about a nice round of applause for Scott Lee?